Hi, I'm Jim, W6LG, your Hammer Radio Elmer here on YouTube. Welcome to my radio room in Rocklin, California. Received a note from David Hall, W6DGH. David asked the question, should he spend a lot of effort, really, to improve the SWR on his current antenna that's sort of an end-fed and maybe more like an off-center fed dipole. To answer his question, I created a table with a bunch of numbers on it, and basically it is what happens when the SWR is 3.2 to 1, what happens when the SWR is 1 to 1. We're going to take a look at that now, see if we can come up with an answer. David's feedline, by the way, is 40 feet of LMR 400. Let's go take a look at the numbers and see what they look like. Okay, so let's look and see what the differences in loss is at various SWR readings. And before we do that, let's come back to me and discuss what happens as the SWR changes. So just to explain in a really rough way, and I'm going to exaggerate some of the losses to make the point. Let's say your transceiver can transmit a pulse, and that pulse of RF goes through the coax and to the antenna. And let's say the SWR is such that about 50% of the power gets radiated and about 50% of the power gets sent back down the coax. And let's assume the coax is really lossy. Let's say it's 50% efficient. So it could be on 6 meters, could be on 10 meters. That pulse goes down. Let's say it's 100 watts. So you create a 100 watt pulse, goes down the coax, gets to the antenna. By the time it gets to the antenna, 50 watts is available for the antenna to radiate. And let's say it decides that, well, I'm going to radiate half of that power. So 25 watts goes out into space. 25 watts gets sent back to the transceiver. By the time it gets to this transceiver, it's 12.5 watts. It turns around and goes back to the antenna, and in round numbers, it's about 6 watts. 3 watts gets radiated, gets sent back and forth until the power is completely dissipated in the coax. How much is radiated? Well, let's say around, pick a number, let's say 30 watts. So that's what happens when the SWR is high and the coax is really lossy. What happens if the coax has zero loss? Well, the power goes down to the antenna, it radiates what it wants to, it reflects it back to the transceiver, turns around and goes back and forth, back and forth. But in each trip of the coax, in theory, there's virtually no loss. There is some loss at the transceiver, but let's just say for discussion, it's zero loss. So that 100 watts hits the antenna, and ultimately, much of that 100 watts gets radiated. To show that in the chart, let's go look at the numbers that I generated and see if we can find something that matches what I just described. Okay, so here's the table I was talking about, and we've got feed line, the length of the feed line, the frequency of the transmitted signal, the output power from the transceiver measured at the transceiver, the SWR, and these will stay virtually the same for each of the kinds of coax in the category of SWR. So in this first category, we're going to have 3.2 to 1 or 3 to 1. And let's take a quick look and see what the effective radiated power is, assuming a dipole antenna and the efficiency of the system. So let's say you've got RG8X, 100 watts, 28.5, 100 feet, 100 watts output rather, 3.2 to 1 SWR. Losses due to SWR that we talked about, about 3/4 of a dB. Total loss about 2.4 dB, which is equal to about 42%. So the efficiency of the antenna is 58%, If it's a dipole antenna, we could say that the effective radiated power, since the dipole has no gain, would be 58 watts. Let's look at LMR 400, same. Now the SWR loss is 0.4. Why? Because LMR 400 is a lot less lossy than RG58 or RG8X. And in fact, in this case, we can say it's about half the loss. So 1 dB is lost. The efficiency of the system is 78%. A dipole with no gain would allow about 78 watts to be radiated. Let's look at ladder line. 100 watts, 28.5, length 100 feet, 100 watts, 3.2, SWR loss, 0. Efficiency of the antenna system, about 89%. So 89 watts gets radiated. So not quite double, but enough to make a difference where you probably could hear it if the feed line is long. I'm not done explaining this, so hang on just a second. So that means on receive, signals are also going to be stronger. Now let's look to say, okay, let's say we've got a perfect SWR, not because of a matching device at the transceiver, but because the match is actually 1.0 to 1. So 1 to 1. Really hard to get there, and that's a whole nother discussion. RG58, for example, it would have about 1.9 dB because that 1.9 is the loss in the coax. If you had an SWR loss, it'd be 1.9 plus 0.9 or 2.8. In this case, it's just 1.9, about 64 watts gets radiated. Let's scoot on down to the ladder line. Again, it's 100 feet, 100 watts, perfect match. Loss due to SWR, 0. Feed line loss, virtually, remember I talked about virtually nothing. That amounts to about 3 watts being lost out of the 100. So 97 watts gets radiated. So, for example, if you had this situation where 97 watts was the effective radiated power, and you could switch over to another antenna with RG58, you'd really hear the difference because there it's about 3 dB or about double. Now, let's say you've got a Yagi antenna that's got 6 dB gain. So again, 100 watts, 100 feet of feed line. We're assuming a 1-to-1 SWR. Again, really hard to get to. The efficiency of the antenna before the gain is about 86%. If you figure, and that's about 86 watts, and the Yagi has 6 dB, we'll say dBd gain. That's about 4 times each. 3 dB is a doubling, so it's double and double again. So in round numbers, about 342 watts. Now let's say, like me, that you're using 7/8 inch hardline, and I do have an amplifier at 1500 watts. The loss in dB is about, in the feed line, is about 0.19 or almost nothing. So 96% efficient. I've got 6 dB gain. Guess what? I have an effective radiated power of 5,700 watts. Now the DX station that I'm trying to contact, is he going to hear this system or this system? And that's why 1,500 watts with a good match, an antenna that has some gain, really pays big dividends. Again, 5,700 watts is compared to 52 watts, about 100 times stronger. It's an enormous difference. So I ran the numbers on David's antenna, and right now the efficiency is somewhere between 90 and 95%, depending on the band that he's on. Even if he makes an improvement in the SWR, the system probably is going to show a slight improvement. Might go to 98% versus 95%. So my recommendation is no, don't make any changes. Enjoy what you're doing. And David's working the world, and here's a map of the places that he's talked to. Now, how is he able to do that? He's got 100 watts, frankly, a somewhat mediocre antenna. And his location is in Los Angeles with a lot of noise in South Pasadena. So to answer the question, Dave listens. David tunes the bands and looks for weak signals and then calls them once he gets their call sign straight. So David's a consummate DXer. He's not depending on the cluster to tell him what DX is around. He's looking and listening and tuning and tuning and tuning and tuning again. So he may go away from the transceiver for a while, but he'll come back and tune again, looking for that DX station. So to answer Dave's question posed at the beginning of this video, should he change his coax to a different kind or try to improve the SWR of the antenna? And the answer is no. Leave it alone, work some DX, have fun with it. When you get a different kind of antenna, then we can talk some more. Thanks for watching. If you have not subscribed, please do that. Would very much appreciate it. I'm Jim, W6LG in Rockland, California, saying 73.